Good day! Welcome to the first educational video to be presented by the Academic Support Group in Programming. The group will focus on the programming side of Arduino. We will start on the introduction of Arduino programming, so let's start on learning. Arduino is an open source hardware and software company based in Italy. Arduino has several microcontrollers that allows users to create interactive devices and projects with the use of its programmable I/O pins. The programming language used in Arduino programming is C++. Arduino sketches are based on C++ with additional libraries to provide functionalities to the microcontroller. It is beneficial and important to understand and familiarize the programming language to create and construct functional sketches. I know that some of you are already familiar on how Arduino microcontrollers are programmed in order to create an interactive device. But for those na bago sa Arduino, it is important to have a background and preliminary knowledge para mas maging madali para sa atin ang pagpoprogram. Now, let's jump to the Arduino IDE. Arduino Integrated Development Environment or Arduino IDE is an open source software for writing and uploading codes to the microcontroller. It is the compiler commonly used in programming Arduino microcontrollers. Ito ang nagsisilbing Microsoft Word ng Arduino. Dito natin ilalatag at gagawin ang coding process in order to give life to the Arduino boards. In this software, we can include libraries, several tools, and necessary information in Arduino programming, such as ports, serial monitor, example sketches, and etc. To start the Arduino journey, kailangan natin ma-acquire ang software by downloading it on the official website ng Arduino. Now, let's talk about the program itself, or also called as the Arduino Sketch. Originally, it only has two required parts, but I added the header part since it is also important in programming the Arduino. The header is the part where we are able to define variables, data types, pins, and libraries to be used. It is where necessary information is presented. It is followed by the setup part, or presented as void setup. The codes under this area are executed once. It is where initialization, categorizing pins, and telling the microcontroller what are to be executed once upon boot up. So, what is the difference on defining pin on the header and categorizing pins on the setup part? Ang sa header ay ilalagay natin kung anong pin nakalagay or nakakonect yung ating components. While on the setup part, we will tell the microcontroller if the connected pin is to be used as input or output. Lastly, the void loop part is where the actual process and function are laid out. The program under this area is to be executed repeatedly. This commonly contains the conditional statements, data acquisitions, and response of the system. But the Arduino allows users to create our own functions so that we can easily manage the program. We can treat these parts as building blocks where it helps us on assembling and forming the entire system. After creating our own functions such as response block, we can now include it to our loop programs. It will be easier to understand the set parts on the next discussions to be uploaded by the academic support group. Now, let's talk about different types of conditional statements that are very useful for the system's decision making. The first example under conditional statements are the if statements. The if statements are used if we want to execute a block of code once it is met, and if it is not met, the flow of the program will skip on it. One example is when we use a motion sensor. We can tell the microcontroller that if it detects motion, a buzzer will beep, but if none, the buzzer will not do anything and the flow of the program will go to the next decision-making statement. The next example is the if-else statements. In if-else statements, the user commands the microcontroller to check if a condition is true, and it will execute the code within the first set of curly braces. And it will execute the code within the second set of curly braces if the condition is false. So ito ay ginagamit sa cases na may gusto tayong gawin once na hindi na-satisfy yung sinet natin na condition. Ito ay madalas na ginagamit on providing control on the variation of data. For example, we created a motion detection system. If there is a motion detected, the buzzer will beep, and if not, the system will indicate that there is no motion detected. Next is the if-else-if statement. It is used for checking multiple conditions in a sequence. Ito ay similar sa if-else statement, but yung else part natin ay may kailangan din na i-meet na condition. If the first condition is true, the code within the first set of curly braces is executed, and the rest of the conditions are not checked. If the first condition is false, the program checks the next condition and so on. Next type of conditional statement is the nested if statement. It is a conditional statement used for checking multiple conditions within each other. It is commonly used for providing a system and process for the variation of data by defining ranges. It is where the two or more conditions are required to be true in order to proceed to the response or block of code. Last example is the switch case statement. It is similar to the if-else-if statements, but it uses cases to provide condition. A switch statement compares the value of a variable to the values specified in case statements. When a case statement is found whose values matches that of the variable, the code in that case statement will run. The 5 types of conditional statements are very useful in Arduino programming, as it helps on providing decisions and proper response of the system. As electronics engineering students, we aim to automate things, and through conditional statements, it is possible. Now, let's hop to the typical Arduino workflow. First, we need to select and install necessary package for the board we will be using. It is followed by writing and creating the sketch on the Arduino IDE. Next step is we need to compile the sketch in order to check and verify the program. It is also a process where the sketch is converted into a binary data so that the microcontroller will be able to understand it. The next step will be uploading the compiled sketch to the board. We need to ensure that the right port is selected and other information are configured according to the board we are using. The last step will be, after uploading, we need to observe and verify physically if the system behaves and works appropriately. Now, let's talk about some key concepts in Arduino programming. First is the setup or void setup. It is the part of the sketch where programs will be executed once. Next is loop or void loop. It is a part of sketch where programs are to be executed repeatedly. Third is the libraries. Libraries is the collection of codes to expand the microcontroller's functionalities. Fourth is digital I/O. The digital write and digital read command is used to control and read the digital pins. It is followed by the analog I/O, where analog write and analog read are used to control and read the analog pins. And last is serial communication, where send and receive of data from microcontroller and computer. To end the discussion, I want to share some tips that is very useful and helpful in working on the activities and projects related to Arduino. First is to always remember and practice the fundamentals. Fundamentals, or the most basic program, is very helpful on troubleshooting and locating errors and problems. Based on my experience, I always start programming on the most basic part of the sketch, and the additional features or complex programs ay dinadagdag ko na lang once the main or the simplest feature ng system ay working na. Next is to be creative and efficient. In programming, being creative on providing functionalities and solution is very important. It requires proper layout, logic, and process to provide efficient functionalities. Last will be do a research. In programming, we didn't need to memorize the syntax. The only thing we need to do is to have the capability to think and provide logical way on solving problems. And creating functions and doing research will help on improving and exposing us to the existing solutions to the problems that we may encounter. And that's all, and keep on learning mga ka-ECE.